In this video, this is talking about the gravitations. We'll focus on the law of universal gravitations introduced by Sir Isaac Newton, and we will discuss also the laws of planetary motion by Johann Kepler. Gravitation is the natural phenomenon by which all things with energy are brought towards one another, including stars, planets, galaxies, and even lights and the subatomic particles. Johann Kepler provides his laws of planetary motions. In his first law, he said that the path of the planets about the sun is elliptical in shape, with the center of the sun being one of the focus. And this law is called as the law of ellipses. So, therefore, the sun is considered as an stationary particle because it has a large mass, and all planets will rotate to the sun, and the path is an elliptical in shape, where the sun being one of the focus, because in ellipse we have two focal points. So one of the focus is where the sun was located. In his law number 2, he said that an imaginary line drawn from the center of the sun to the center of the planet will sweep out equal areas with equal interval of time. This law is called as the law of equal areas. So therefore, in this law, suppose these are the sweep areas with equal time interval. So for example, at this point, suppose this is the initial point of the Earth, then move to this point. So if we connect a line from this point towards the center of the sun, so we are providing the area. We call it as a sweep area. So the time of travel from initial point to the final point T is the same as the time of travel for this point, then move to another point. Now remember that uh, when the particle moves closer to the sun, the motion is keep on increasing, and it is slowing near away from the sun, but closer to the sun, particles will move in fast velocity. So therefore, if this is another point of travel, which is this is closer to the sun, so it has a large displacement, but the time is the same. So if we connect all these lines towards the sun, so we are providing the area. We call this a sweep out area. And this is also another area. These two areas are the same. So this is the second law of Kepler, the law of equal area. So therefore, all shaded portion here must be the same, provided it has the same time interval, which means that this time is the same as this time. So therefore, the area must be the same. In law number 3, we call this as the law of harmonies. According to this law, the ratio of the squares of the period of any two planets is equal to the ratio of the cubes of their average distances from the sun. Meaning that, take note that Earth is moving around the sun. So in one complete revolution, we call that as the period of the travel. So the time of one complete revolution is the period. According to the law, if you square the period and divide the cube of their distance from the sun, distance means the radius, and it should be the average radius. If you square the period, then cube the average radius from the sun, the result is constant to all planets which are moving around the sun also. Which means that if we calculate this one, the period again is the time of one complete revolution. then the radius is must be the average radius from the sun towards the planet. If you square the period and cube the radius, it is always a constant value, and it provides a constant number. So therefore, all planets must obey this result or this equation. So this is the third law of Kepler, the law of harmonies. Okay, now the laws of motions, planetary motions of Kepler was the basis of the law of universal gravitations introduced by Sir Isaac Newton. He used the idea, some of the ideas of the laws of Newton's, laws of Kepler, and applied that to the law of universal gravitation. Now, the law of universal gravitation means that any two bodies in the universe attract each other with a force. Okay? That is directly proportional to the product of their masses and inversely proportional to the square of their distance between their centers. So therefore, this law says that if we have two particles, let us say mass A, mass B, the two particles must interact. So therefore, there must be a force on the two particles because of their uh, interactions. So for example, we have the mass A and we have mass B. Then they are spaced at a distance r. Okay. Now take note that these two particles will interact. This is according to the law of universal gravitation. Any two or more objects will interact each other, which means that since we have this mass A and we have mass B, ignore other effect of the other. So assuming these are the object are focus only the interaction, which means that imagine a vacuum and there is only the force is only the results of the interactions, then according to this law, mass A must experience a force due to mass B. At the same time, mass B will experience a force due to the gravitational attraction of the mass A. Okay, so therefore we have this force, and take note this force is the force that B exerts on A. That's the meaning of BA. The force that B exerts on A. Now, take note that the direction is towards the object, towards the interacting object. So therefore, again, this force is the force applied by B. Now, similarly, B also exerts a force on A, which means that, okay, okay, change this one. This should be force that A exerts on B. Okay. So therefore, again, this is the force that A exerts on B, while this one is the force that B exerts on A. So take note that they are of the same magnitude but in opposite direction. This is actually pattern with the third law of Newton. But in the third law of Newton, for every action, there must be equal and opposite amount of reaction. But we discussed that because of the contact. But this one, there is no contact. But remember, there are two kinds of forces. We have the contact force and we have the long-range force. So therefore, these forces are long-range force. So this can be considered as the action force, while this one, the force that A exerts on B is the reaction due to action force. Okay, so the law says that the force, which is this one, okay, now take note that, remember, they have the same magnitude but in opposite direction. So therefore, if you sum up the two, the result should be 0. So therefore, these forces are the same. So we can say it, let us say for simplicity, F. Now, according to the law, this force, which is the same of these two forces, is directly proportional to the product of their masses. Which means that if we multiply mass A and mass B, the force is directly proportional. The greater the product, the greater the force. So therefore, mathematically, we can say that the force of gravity between the two interacting bodies is directly proportional to the product of their masses, mass A times mass B. So, this is the meaning of this. Directly proportional to the product of their masses. And, okay, another statement is inversely proportional to the square of their distance, center to center. So, take note, distance, center to center, meaning from the center of the mass A and the center of the mass B, their distance in between is called as radius and call this as R. Now, according to this law, this force is inversely, when we say inversely, the greater, the smaller. So, then inversely the square of the distance between their center. So, therefore, this is the mathematical presentation of that. Force is inversely proportional to the square. The first statement says that the force is directly proportional to the product of their masses. The greater the force, the greater the distance, the smaller the force. Okay? Now, take note that we don't want the proportionality result. We need the equality. Means we will create equations. So, take note, if we combine these two statements, that the force is directly proportional to the product and inversely to the square of their center to center distance. Okay? So again, we are uh, interested with the sign of equality, not for the proportionality. So with that, we will change the proportionality symbol to sign of equality, but take note that they are not equal to the product and the square of the distance. So there must be something that balance the equation. So therefore, this must be a constant, which means any masses and any distances, this is always the same mathematically. Okay, because this will take care of the sign of equality. So therefore, this is the formula for the law of universal gravitation, where F is the gravitational force, means this is the result of the gravitational attraction, and the unit must be in Newton. And remember, force is a vector, so there must be magnitude and direction of this force. Mass A and mass B are the interacting masses, so the unit should be in kilogram for SI. This can be pounds in English system, okay? Or this can be a grams per CJ system, but in SI, this should be kilogram and this should be in Newton. R is the distance between masses. Take note, distance is center to center. Center of the mass and the center to another mass. Connect a line that and that will be the distance between masses. We assign small letter r. For we can say it radius because anywhere, as long as this is r, this should be the center to center distance. Okay, then this G is, take note, this G is, for in mathematics, this is to balance. But in physics, we call this as the gravitational constant. And the value is constant. We can use this any particle that interacts 6.67 times 10 raised to the 11. Take note of the unit. Newton meter square per kilogram square. Okay, so therefore, we can use this if we will be using this formula. So you have to memorize this one. Again, the gravitational constant is 6.67 times 10 raised to negative 11 Newton meter square per kilogram square. Okay? So look at this formula. Remember that it is directly proportional to the product of their masses, which means that if one of this or if one or two of this increases its mass, then force also increases. But take note that if we have two objects, if your R is greater than the initial, which means that if we move the particles away from each other, you are increasing the amount of radius. Remember, force decreases, which means in a far away distance, very far away distance, the force becomes zero. But if they are closer to each other, if we let the two particles move towards each other, you are reducing the center to center distance, so you are increasing the amount of gravitational force because it is inversely proportional. Okay, so therefore, again, this is the formula for the law of universal gravitation. This can be applied to any object. For example, you have object A and object B. Let us say a stone and a metal ball. You have the mass. If you have the center to center, you can always calculate the amount of the gravitational force, and that's the result of the attraction. Okay, we can also apply this because this is universal, which means that this can be applied anywhere, which means that take note that the earth is an object and the moon is also the object, so therefore there must be a force between the earth and moon. Also, because we are rotating around the sun, so therefore there must be a force that the sun exerts to the earth, and there is also a force that earth exerts to the sun. And remember, the two forces must be the same. Okay? So, in order to exercise the formula, we have to solve this problem. Problem number 1 says that calculate the force of gravity on two interacting objects whose masses are 50 kilograms and 65 kilograms, and they are separated at a distance of 2 meters. Okay? So, the weight of 50 grams and 65 grams can be the weight of the two persons with masses 50 kilograms or 65 grams. So it can be any particle as long as they have the masses. Okay? And the distance between them is 2 meters. The question is, how much force? How much force exerted by the two particles each other? Remember, forces are the same. So, to provide a solution of this problem, let's say mass A has 65 kilograms and we have mass B 50 kilograms mass. And the distance between them is R, and R is 2 meters. The question is, how much force of gravity experienced by each particle? Okay? So, we are to solve this force. Remember, this is the force on A is the force that B exerts on A. Okay? This is the B that force on A. Then, at must be, there must be also a force that A exerts on B. So, we will change again. This is B that A that force that A exerts on B. Okay, so how much is this force? Remember that these two forces are the same, so we can see it for simplicity F again. Now, according to the law of universal gravitation formula, that this force is equal to the product of the gravitational constant times the product of the interacting masses divided by the square of their distance. Now remember, G is 6.67 times 10 raised to 11, take note the unit, Newton meter square per kilogram square. So this must be the unit in order to produce a unit of Newton for the force. Remember, this is kilogram and kilogram, so this will be cancelled out. And this is meter square, so this will be cancelled also. So therefore, the unit, if you're calculating force, the unit should be in Newton consistently. Okay, let's substitute the values. Okay, now take note that G is 6.67 times 10 raised to 11 Newton meter square per kilogram square, and the masses are 65 kilograms and we have the 50 kilograms divided by their center to center distance, 2 meter and raised to 2. So look at the unit. Kilogram and kilogram, this should be kilogram square, so therefore this will be cancelled out. This is 2 meter square it, so we have 4 meter square. So the meter square now will be cancelled out. So our unit now is in Newton. So use your calculator, and the answer says that the force between the two particles is 5.42 times 10 raised to negative 8. Okay, look at this result. This is a very, very small result. Okay, so the question is, why is it that if this is true that there is a force, why is it that this particle will not move towards this object? What do you think? Why, if the law is correct, now there must be a force, why is it that this mass A cannot move towards B by this force? The answer is, take note that mass A interact to the Earth. And remember, Earth has a greatest or greater mass compared to other particles on Earth. So therefore, the force between them must be greater also. So therefore, this object, mass A, will move towards the Earth. Not that mass A move towards B because of the gravity. Because the Earth generates large mass or large gravity because of its large mass, then it follows that this object must move towards the Earth. Now remember that gravitational force, weight of the particle is gravitational force. So it is the force that the Earth exerts on this object. So if you compute the weight, remember weight is mass times gravity. So you have to multiply 65 by 9.81. So if you compare that with the result of 5.42 times 10 raised to negative 8, this is negligible in number. So therefore, this particle cannot move towards B. Instead, this will move towards the Earth. Also with mass B. Mass B cannot move towards A. Instead, this will move towards the radius of the Earth. Why? Because again, remember, if two bodies interact because of its mass, Earth also with these masses will interact also to the Earth because Earth has a mass. And the significant force is towards the Earth. Okay? So, the direction, remember, force is a vector's quantity. So, for now, we can say that the magnitude of the force is 4.5.42 times 10 raised to negative 8 Newton, and the direction is directed towards each other. So, they will be moving, the direction should be towards each other. But remember, this won't move physically towards each other. Why? Because another force exerted by Earth. Now, if there is no presence of Earth here, then this object will move towards each other. Take note, vector sum. Okay? So, again, the amount of 5.42 times 10 to the negative 8 is the amount of force here, which is the same as the force. Regardless of this is greater in mass compared to this one, therefore, their interaction must be the same. So therefore, if we analyze the interaction of this object with the Earth, then whatever force that the Earth exerts on this particle, the particle also exert a force the same amount to the Earth. And the formula is the law of universal gravitation formula. Okay? So this is the solution for the problem number 1. Calculate the force, and we have only two masses surround, or if we have two masses, then there must be a force due to this mass, and we have the force also exerted by this A towards B. Now the question now next is, what if we have another object in the surrounding area? The question now is, how much force that A exerted by the two objects. Now, if that's the case, we call that as the superposition of gravitational force. Meaning, if we have two or more surrounds a particle, two or more, we call that as superpositions of gravitational force. So, we have here the problem number 2 to explain the principle of the superposition of the gravitational force. This is a problem. Many Mars belongs to the system of two or more stars held together by their mutual gravitational attraction. Okay, we have this figure. So the figure says that we have three stars. Okay, three stars. We have star 1, star 2, and star 3. The star 1 has a mass of 1 times 10 raised to 30 kilograms, while mass 2 and mass 3, both of them have 8 times 10 raised to 30 kilograms. So therefore, if you compare the three, the star 1 has a smallest mass, okay, among the three. So therefore, now the problems is that we have this 45 degrees in an angle. They are forming right triangle, okay? And we have this, the distance between 2 and 3 is 2 times 10 raised to 12 meter, while the distance between 1 and 3, center to center, the center to center, is 2 and 2 times 10 raised to 12. So therefore, they are equidistant. The distance from 1 to 3 and distance of 2 to 3 are the same. And remember, this is right triangle. So in geometry, this is a kind of equilateral right triangle. Isosceles right triangle because the two sides are congruent, not equilateral. Because equilateral, three sides must be the same. So it happens that the three angles also must be the same. This one, two sides must be the same, and the two angles must also the same. So this is isosceles right triangle. Okay, so the question now is find the total. Okay, when we see total, it is a net force. And remember, net force is, remember, it is what? It is vector. This is force, sorry, this is force. So this is force. Find the total or the net force exerted by what? By exerted on the small star. This is the small star. By the two large ones. These are the two large ones. The mass 2, star 2, and star 3. So therefore, we will focus on the object, Mars 1. How much is the total force on this object? Remember that this is a superposition. Why? Because there are two or more that surrounds the object. So therefore, we have two forces acting on this particle because there are two objects. Unlike in our problem number 1, we have only two objects, so therefore we have only one force exerted on mass 1. But remember, there are two that surrounds this object, so therefore there must be two forces acting on this particle. Okay. If there are two on 1, there are also two on star 2. Okay? And there are also two forces acting on the mass or star 3. Okay? So if you notice this one, if you analyze forces on 2, we have a force, okay? There's a force that one exerts on 2, and we have the force, look at this line, the force that 2 exerts on, or 3 exerts on 2. Okay? While this one, if you analyze this one, there are two forces acting on star 3. We have the force that 1 exerts on 3, the direction is towards 1, and the other one is we have the force that 2 exerts on 3, towards 2. Okay? But in this problem, the question says that find the net force exerted on mass small star, okay? This is a mass of 1 times 10 raised to 30 kilogram by the two large ones. Okay, so there we will focus on the uh, force on mass 1. That's why we overlay the Cartesian on the mass 1. So therefore, this is y and this is x. So we can say that the star tree is lying along the positive x of the axis at a distance of 2 meter, 2 times 10 raised to 12 meter. Okay? Now, while star 2 is located at the first quadrant of the Cartesian, whose coordinate is 2 times 10 raised to 12, and 2 times 10 raised to 12. The abscissa and the ordinate. Okay? So, what are the forces and what direction the force on 1? Okay, let's analyze. Now, remember that 2 exerts a force on 1. Okay? So, this must be the direction. This is the force that 2 exerts on 1. So, this should be from the center of the star 1 towards the 2, connecting this line. Okay? So then, another force on 1 is the force that 3 exerts on 1. So, it is towards the x-axis. While this force has the component of x and component of y. Okay, take note, force is a vector. So, we have to apply our vector analysis here in order to answer. Now, when we say total, remember, it is not the algebraic sum of the force that 2 exerts on 1 and the force that 3 exerts on 1. It should be the vector sum. Remember that vector sum is different from the algebraic sum. So, force should be a vector sum. So, in order to solve for the vector sum of these two forces, we need to solve first if the 2 exerts on 1 and the if the 3 exerts on 1 using the formula of the law of universal gravitation, which means that, look at this one. In order to solve this force, the 2 exerts on 1, remember J is 6.67 times 10 raised to negative 11, and this mass A should be any of these two. So let us say 1 times 10 raised to 30 for mass A, and this is mass B should be 8 times 10 raised to 30 kilograms. So multiply the 2, weigh the constant, divide it by what? The center to center distance. So where is the center to center distance? We cannot use 2. Why? Because this 2 is center to 3 and center to 2. And this other 2 is center of 1 to center of 3. We are looking for from a distance from the center of 2 and the center of 1. So therefore, when we say R, it should be this one. Center to center. Center of star 1 and the center of star 2. This is the distance from 1 to 2. Call it distance from 1 to 2. So therefore, we need to solve this one first. Because we cannot solve this force without R. So, Pythagorean theorem, this is right triangle, remember. So, we can solve always the hypotenuse. This is a right triangle, is from 1 to this an hypotenuse. So, we have the two sides. Take the square root of that, okay? Take the square root of that, then square. Square this one, then take square root. Then the answer is 2.83 times 10 raised to 12 meters. So therefore, again, this is 2.83 times 10 raised to 12 meters. So we can replace that. Okay, this is now the distance center to center from center of the mass 1 and center of the mass 2. So we have this 2.83 times 10 raised to 12. Remember, this is 2 times 10 raised to 12 and this is 2 times 10 raised to 12 also. Okay. Another force, okay. So therefore, we are now ready to solve this one. What about this one? Now to solve this is, again, consider the two particles, star 1 and star 3. So therefore, to solve for the force, again, use the gravitational law of universal gravitation formula. Then it should be the constant times the mass of 1, this is 1 times 10 raised to 30, times the mass of 3, star 3, 8 times 10 raised to 30, divided by the distance center to center. Now in this case, we can utilize the 2 because this is center of 1 and this is center of 3. So therefore, nothing to worry. We can solve the force that 2 exerts on 1 and we are now ready to solve for the force that 3 exerts on 1. We need this 2. Why? Because we will find the vector sum of these 2. We cannot find the vector sum without the values of these 2. So, first thing to do is to calculate the forces on 2 exerts on 1 and the force that 3 exerts on 1. Everything is on 1. So, therefore, we are focused on the force on 1. So, to do it is the constant. This is 2 exerts on 1. Okay? This is the constant 6.67 times 10 raised to 11 Newton meter square per kilogram square. This is G. multiplied by mass A. So we use mass A as 8. 2 times, okay, this is 8 times 10 raised to 30. While this is the mass of star 1. And this 1 times 10 raised to 30 kilograms. Distance, center to center is 1 to 2 is 2.83 times 10 raised to 12 meter, then square it. Okay, so you can use your calculator. Remember that we can cancel kilogram square again. We can cancel also the meter square. Then the unit is automatically Newton. So actually we can ignore the units as long as we use the SI units for all the quantities. Then we will provide the unit on SI on that quantity that we are about to solve. So, okay, this is showing us that we can cancel the unit and leave this Newton for the unit of force. Okay, so then calculate. The answer says that 6.67 times 10 raised to 25 newtons. This is a very large force. Take note. This is positive. So therefore, this is a very large force. This is the force that what? 2 exerts on 1. So we are done calculating this force. Next, proceed to the force that 3 exerts on 1. So 3 exerts on 1. Again, the constant, the gravitational constant, you have to memorize this always because we will be using always if we are talking about gravity. Okay? Then, mass 3, this is mass 3. Okay? 8 times 10 raised to 30 and 1, the interacting mass is 1. So we have 1 times 10 raised to 30 kilograms divided by the distance from 1 to 3. This is 1 to 3 or 3 to 1 is 2 times 10 raised to 12. Okay, then calculate. The result is 1.33 times 10 raised to 26 newtons. Okay? So, we are already calculated the two forces. That these two forces are the forces that act on this star 1, the smallest star. Now remember the question is find the total. Again, reminders that the total gravitational force, okay? The total gravitational force should be the net force. By the way, you have to change also this one. This is force, okay? The net force. So therefore, we have to use our what? We have to use our ability in finding the resultant or the vector sum. You have to express this in terms of I hat and j hat for simplicity. Okay? So if you are providing the vector sum in terms of I hat and j hat, that's the answer. That's the complete answer to this problem. So we will provide the net force in terms of I hat and j hat. So take note, you have to recall the vectors, the unit vector involvement in order to make simple of the presentation of your answer. Okay, so we will keep these two values. These are the force, the 2 exerts on 1 and the 3 exerts on 1. So we will keep that answer. Okay. So, this force, again, the 2 exerts on 1 is 6.67 times 10 raised to 25, while the force, the 3 exerts on 1 is 1.33 times 10 raised to 26. Now, we are looking for this net force. This is the net force. This is the force that the net force on star 1. And it should be equal to what? The vector sum. This arrowhead means vector sum. The vector sum of of 2 exerts on 1 and the force plus vector force that 3 exerts on 1. Remember, these forces are the magnitude of this vector. This is magnitude while this one are vectors. So these are the vector sum. So we need to express this force. This is very important. Express this force in terms of unit vector. So this is to remind that if you need to have the idea of converting the force in terms of unit vector. So if you cannot convert this, you are advised to see my video on the expressing vectors in terms of unit vector. So we will express this force in terms of unit vector, and also the force that 3 exerts on 1. Okay, so take note that the force that 2 exerts on 1, it has a component along x and component along y. Okay? It has a component of force along x, and we have the component along y. In this case, this is x component and we have the y component. So they are on the first quadrant, so all unit vectors must be positive. So this is positive I hat and this is negative j hat. This 6.67 times 10 raised to 25 is the magnitude of this force. Now since we are looking for the x, because this is the x component, we need to use the cosine, because cosine is adjacent to the angle. Okay, the side, this is adjacent, so therefore this must be cosine. Again, review my video on expressing unit vector. So the x component of this vector is 6.67 times 10 raised to 25 cosine of 45 positive I hat. Okay, then this should be added by, okay, another typographical error, this should be plus. Okay, so add the positive, then insert the positive. Okay, then this is the same 6.67 times 10 raised to 25, and this time this is sine. Why sine? Sine because this is opposite. The y component is opposite to this angle, so therefore this must be sine. So calculate, use the calculator, evaluate this cosine and sine, then we have this answer. This is the vector. Remember, this is just magnitude, so this is not a vector presentation of force onto with direction, with direction. So this is the force that 2 exerts on 1 is equal to 4.72 times 10 raised to 55 I hat, positive, which means towards right, plus the 4.72 times 10 raised to 55 upward, above, towards the positive y-axis. This is positive j hat. So again, this is now force that 2 exerts on 1 in a vector presentation. So then next is we have to express again this force that 3 exerts on 1 in terms of its unit vector. But take note, be careful. This is directly towards x. Okay? Towards positive x. So, therefore, there is no component along y, unlike this one. Unlike this force that 2 exerts on 1, we have the component of x and component of y. So, the force that 3 exerts on 1 has no component along y. So, therefore, this is a simple way of converting of the force in terms of unit vector. You have to use, take note, the magnitude of this force of a certain one is 1.33 times 10 raised to 26, and simply multiply it with the unit vector positive because this is towards positive x. And the y component is automatically 0, so we can notice we have only one term here. Okay, so therefore we are now ready to solve for the problem. Why? Because this is the vector that 2 exerts on 1 force. This is the one. While the force that 3 exerts on 1 is 1.33 times 10 raised to 26. So we will substitute these vectors to this answer. But remember, when we substitute, it is geometric. So you have to be careful. Use your vector algebra. So this one is the force that 2 exerts on 1, and this is the force that 3 exerts on 1. Take note, we have like terms. The like terms in vectors algebra are terms that have the same unit vector. So this is I hat and this is I hat. So therefore we can combine this algebraically. So we can use your calculator to add these two values. This one we cannot add terms because we have no other terms that involve z hat. So therefore add the 4.72 times 10 raised to 25 by 1.33 times 10 raised to 26. And the answer is 1.8 times 10 raised to 26 I hat plus 4.72 times 10 raised to 25 g hat. This is the vector. This is the force on small star due to the surrounding stars. Okay? So this is the complete solution to the answer. Now, by the way, what if you are asked what is the magnitude and direction of the net force? Okay? What will be the magnitude? Because this is take note, this is a complete description. Because we are presenting the vector in terms of unit vector, we have already the magnitude here, and we have also the direction. The direction is, look at the unit vector. This is positive and positive, so directed towards in the first quadrant. Okay? If one of these, if, for example, I is negative, so therefore, if the negative, then it follows that the force is directed towards the second quadrant. If three are negative, then in the fourth quadrant, third quadrant, now if J is negative and I is positive, then you are on the fourth quadrant. So therefore, again, direction was already identified if you present this as an answer. But there are questions that you might be asked. Calculate the magnitude and direction. So to answer is, you can use this one. You can use this one because this is a complete information about the vector. So we will preserve that one. And we are now on the way to solve for the magnitude. Okay. To solve for the magnitude, you just take recall your vector again, analysis. In order to find the magnitude of this net force, take note, we use the symbol for absolute or remove the arrowhead on the top of it, and this is automatically the magnitude. So if you are looking for the magnitude, use the square root. The square root, the square, or take the square root of the square of the x. Take note, this is the x component and this is the y component. So square the x component and the square the y component, then take square root of that, then the answer is the magnitude of the net force. Okay, so this is the magnitude of net force. Then if you want to know what's the direction, we know this is located in the second quadrant, first quadrant. But the question is, what must be the angle? Because there are many angles. If we are talking about in the first quadrant, there are many angles from 0 to 90. So what is the angle, the specific angle that this force, net force directed? So to answer is, you have to use the inverse tan, okay, of the fy over fx. It should be fy over fx. So therefore, the angle must be coming from the x-axis. So if you use, by the way, this formula, actually this is not a formula. This is the, because the components forming a right triangle, then this is opposite over adjacent. Opposite is y, and this is adjacent x. So therefore, we can solve for the angle. So the angle must be based from the x-axis. If you reverse this one, this is fx and fy, you are calculating the angle from y-axis. Okay? So in this case, we are calculating the angle from x-axis. All you need to do is to divide this one. Divide the x, this is the x component, remember? And by the x, this is the y component and this is the x component. Divide that, then take the inverse tan so that you are calculating the angle. And the answer is 14.62 degrees. This is from what? From positive x-axis in quadrant 1. So, therefore, take note, this is 45 degrees. So, if you are asking where is our net force in the Cartesian, the answer is from 14.62, this is, remember, 45, so it's between, it must be between those four. So 14.62, then connect a line, then the magnitude should be what? The magnitude is 1.67 times 10 raised to 26 newtons. So therefore, this is the answer. So this beta, again, this beta is 14.62. This angle is coming from this axis, x towards that line. So this is the angle for 10.62, and the magnitude is the magnitude we calculated in the previous slide. Okay, so that's it. You will be providing this one if you are asked calculate the magnitude and direction. But if there is no question with magnitude and direction, you are asked to find the net the force, then provide this answer only. In terms of, you have to express that in terms of the vector for simplicity. Take note. If you want to make simple to the problem of vectors quantity, then you have to express that in terms of I hat, j hat, or maybe k hat, x, y, z axis. That's it. So, okay, these are the problems for you to answer. So I hope you will solve this one. 1, 2, 3. This is talking about gravitations. So, if there are questions, you need some data. For example, you want to know how much is the mass of the data, or the mass of the Earth, then you have to search it on the website. because there you might be asked, for example, assume the Earth orbits. Okay, this is actually the uh, distance, radius of the circle, or the radius of the Earth. So there are things that you need to use it in order to solve a problem, then go for searching. But okay, take note on the portion that you are asked. Suppose you are asked, calculate the centripetal acceleration to provide the answer. What exert this force on the Earth, for example? So therefore, answer everything 1, 2, 3, and you will be uh, learn about the application of the law of universal gravitation by Sir Isaac Newton. Okay, good luck. So thank you for watching. So see you on my next